is a retroaldol? The retroaldol means going back to their constituent carbonyls. That means a OH minus will attack this hydrogen, this bond will fall and this bond will go away. Hello students, welcome back to another class. Today we will discuss some more organic compounds containing oxygens. So let's start. Now this problem, in here MEI, that is methyl iodide, and KH is excess is given and asked what will be our major product, means 81% yield. What happens in there, this KH acts as a base. This H minus obstructs the most acidic hydrogen. Now in this compound, if we can see, there is an enolate form possible. From either of this side, one hydrogen will form an enolate like this, OH double bond. So all the hydrogen present in this carbon and in this carbon are acidic. So the KH will obstruct that hydrogen from this position like this. H minus will obstruct this hydrogen, this bond will go out there and an enolate ion will form. Now the keto form is more stable than the enolate ion, so it will be back and it will obstruct the methyl from the methyl iodide like this. And this process will repeat itself 3 more times, as because here is 2 hydrogen and here is also 2 hydrogen. That means total of 4 hydrogen, and all the 4 hydrogen will be replaced by this process and the product will be like this: methyl, methyl, methyl and methyl. So option C here is our correct answer. Okay. Now the next problem. In this reaction up to this part is very basic. That means the cyanide will attack this carbon. It will form a cyanohydrin, and upon reduction with lithium aluminium hydride, this part will form like a CH2NH2. Now when NaNO2 and HCl is used, this NH2 will removed and here will be a carbocation will be generated like this. Now this carbocation is 1 degree and obviously unstable. In general, we have a common conception that if RNH2 is treated with NaNO2 and HCl, it will form ROH, but not in this case. In this case, what will happen? This bond will fall here, this bond will open up and go to this position. So if we number it, this will be 1, 2, 3, 4, 5 and 6. So it will be a 6-member ring. The double bonded oxygen will be at position 1 and 1 and 6 will be bonded. So this will be our final product, and hence option A is our final product. But if we go with this reaction, option D could be our final product. So you have to make sure you check all the possibilities, because in this case this is not the possibility due to the stability of 6-member ring is much more than the stability of a 5-member ring. Hence a ring expansion will occur, then a normal hydroxylation. Right, so the next problem. Now they have been asked that on which reaction this compound will turn into this. Now we can, when we have no clue how we can convert this compound into this compound, but remember this is a condition of retroaldol condensation. Now what is a retroaldol condensation? During any aldol reaction, this type of product is OH, CH2, C double bond O. This is a aldol compound, and this is what is a retroaldol. The retroaldol means going back to their constituent carbonyls. That means a OH minus will attack this hydrogen, this bond will fall and this bond will go away. So it will be like this. See, there is always a hydrogen if it is, so this will be double bond O plus CH3, C double bond O, R. So this is a retroaldol condensation. So if we perform a retroaldol condensation in out there, we will find that this is a compound, this is the oxygen and hydrogen, this is the methyl group, and this is the carbonyl group. So retroaldol condensation will occur like this, and a compound, how many compound will form? If this is the 1, this is 2, this is 3, this is 4, so there will be a 4-membered carbon ring, and this is the first carbon, so CH3, C double bond O. There are 3 CH2 groups, so there will be 3 CH2, and there will be another C double bond O CH3 group. So this is a retroaldol condensation. Now this compound will go another aldol condensation to form this one. And how? This time this hydrogen will be removed like this, and this carbon will attack that oxygen to give an aldol like this. We are all habituated on how to perform an aldol, and this product will form. How? Okay, let's check. We have to draw that compound in kind of cyclic position like this. CH3. Now see, this carbon will be hydrogen abstracted, and we have a 3 CH2 group, another C double bond O CH3. So this carbon will attack this here and will form a aldol like this, on which a CH3. Now this hydrogen will be eliminated to give this product. So you can see that this product is formed. So this is an example of retroaldol condensation followed by aldol condensation. So the option B will be our correct answer. Okay. So just remember to perform an retroaldol and another aldol on this type of reaction. Now coming back to the next problem. We'll now come to the next problem. Now LDA is quite similar to the first problem. LDA is a base and it will obstruct the most acidic hydrogen. Now the question is, this one has 1 hydrogen and this one has 2 hydrogen. Now the question is, which one of these will be the most acidic hydrogen? In general, this part is most acidic, but when a bulky base is used, they obstruct these hydrogens readily due to, in this case, the presence of this methyl group will create a steric hindrance for a bulky base. So a bulky base will obstruct less sterically hindered hydrogen, but a small base will obstruct the most sterically hindered hydrogen. Now LDA is a bulky base, so it will obstruct this hydrogen and will form an enolate form like this. So this enolate thus formed will further go back to attacking this ethyl halide, which will form a compound like this. So B here is our correct answer, as we can clearly see. Now if this base is anything else, like in previous case we have used a KH as base, in this case also if we have used a KH, then A would be the major product, due to as it is a small base and it will abstract this hydrogen. But as LD is a bulky base, it will abstract the less substituted hydrogen, and option B will be our final product. Now this problem is easy or somewhat tricky. What happens is basically a base. This base will abstract the most acidic hydrogen, which is this one. So this negative ion will form and this will attack this hydrogen. Will this? No. Here is the twist. This will not attack this carbon. This will attack this carbon because the easy removal of the chlorine, and hence this product will be formed. CH2 C double bond O H. Okay. Now let's remove this part for the time being. Now, due to the presence of base also again, there is another hydrogen which will get abstracted and an enolate will form like this. An enolate will form like this. This will go attack here and this bond will go. So a 1, 2, 3, 4, 5, a 5-membered ring will form. 1, 2, 3, 4, 5. Here is the oxygen. So here is the 5-member ring. There is the O minus H, and here is the double bond O. So this will this hydrogen also gets removed from this position to remove this oxygen also as in water. We skipped a little bit part that this O minus will take up a hydrogen, it will form an OH, then this hydrogen and this OH will remove as in water. We just skip that part, as you can always do it by yourself and it is a very easy step. So this will be our product, and let's find out which one of this is. Well, option A is the correct answer here. In this case, you can see it. So option A is the answer. Okay. Now the next problem is, which one of the following will not undergo Canniger reaction? Now we all know that any carboxylic acid or any carbonyl having alpha hydrogen will not undergo Canniger reaction. Now this does not have alpha hydrogen, so this will go Canniger reaction. This will also go Canniger reaction. But these two compounds have alpha hydrogen in them. So there might be, you might think that this is a multiple correct answer, but this is not, because we know in aldol only one alpha hydrogen is needed, but presence of two alpha hydrogen facilitates the reaction. But in this case only one alpha hydrogen is present, hence it will not undergo aldol. In this compound C, that means CH3 CHCHO will not undergo aldol condensation due to the absence of second alpha hydrogen. So this will also undergo Canniger reaction. But this compound has two alpha hydrogen and is very suitable for aldol reaction. So this will, compound D will not undergo Canniger reaction. So option D will be our correct answer. So you have to just remember that another alpha hydrogen, that means a second alpha hydrogen, is required to facilitate the aldol condensation reaction, and aldol condensation reaction is favored in presence of a second alpha hydrogen. So this will not undergo aldol condensation, rather this will undergo aldol condensation and will not undergo Canniger reaction as we have been asked. Okay, so here we are concluding our reaction chemistry. with oxygenous compounds. Next day we will see another interesting topic. Okay, I hope you have all enjoyed the video. So please like and subscribe the video, and all the best for the examination. Thank you.